Hello and welcome back to Math with Mrs. Becker. This is Pre-Calculus. Today we are looking at the introduction to section 1.3, which covers arithmetic sequences. Now, an arithmetic sequence is a sequence in which the difference between each term and the preceding term is always constant. Okay, so what we're doing is we're going to look at the difference between each term, meaning, are you adding or subtracting the same number each time? Okay, that's what an arithmetic sequence is. It means to get from one term to the next, you have to be adding or subtracting the exact same value. So just to start off, okay, are the following sequences arithmetic? If so, what is that common difference? Okay, so if I go ahead and I'm just going to look at it as, how do I get from one term to the next? How do I go from 14 to 10? Well, you minus 4. How do I go from 10 to 6? Well, you minus 4. To go from 6 to 2, you minus 4. 2 to get to negative 2, you minus 4. Negative 2 minus 4 more is negative 6. Negative 6 minus 4 more is negative 10. So yes, that is an arithmetic sequence. What is the common difference? It's negative 4. From one term to the next, you are subtracting 4. Okay, let's look at another one. To go from 2 to 5, adding or subtracting, to go from 3 to 5, adding or subtracting, you add a 2. To go from 5 to 8, adding or subtracting, you add a 3. To go from 8 to 12, you add a 4. So right here, this cannot be an arithmetic sequence, because in order for it to be an arithmetic sequence, these values all have to be the exact same number. This isn't the same. You're adding 2, then you're adding 3, you're adding 4. So no, that is not an example of an arithmetic sequence. So it does not have a common difference. Okay, the next one. To go from 33 to 27, well, you'd minus 6. To go from 27 to 21, you'd minus 6. To go from 21 to 16, oh, I'd minus 5. To go from 16 to 11, I'm minus 5. To go from 11 to 7, I'm minus 4. Now, the reason I did this one, I wanted to make sure that you realized you do have to try more than 2 values. Like here, if you just did 2, you might have said, hey, that's an arithmetic sequence and the common difference is negative 6. But it's not. You had the negative 6 twice, then it changed to a different number. So no, this is not an arithmetic sequence at all. There is no common difference. Negative 6 occurred twice, negative 5 occurred twice, but the only way that it's an arithmetic sequence is if the number is the same all the way throughout. Okay, one more example. To go from 4 to a 10, adding or subtracting. Well, I would add a 6 to a 4 in order to make it 10. To go from 10 to 16, you add 6. To go from 16 to 22, you add 6. To go from 22 to 28, you add 6. 28 to 34, you add 6. Because every single time you are doing the exact same thing, yes, that is an arithmetic sequence. Your common difference, the common difference is a positive 6. Because what you're doing every time is you are adding 6 more. In an arithmetic sequence, where you see a formula like this, okay? Remember, u sub n minus 1 means take the previous term, and then you add whatever that common difference is. D is how they represent the common difference. So what they want you to see is that, again, you can have this recursive formula. A recursive formula has to contain u sub n minus 1. This means use the previous term. Then from there, you would take the common difference. If it's negative, you would minus. If it's positive, you would add. So let's go ahead and look at another example. If u sub n is an arithmetic sequence, so they're telling us to get from one number to the next, you are adding or subtracting the exact same value. The first term is a 3. The second term is 4.5. Find the common difference. So what you're saying is to get from the first term to the second term. What are you adding or subtracting? Well, to go from 3 to 4.5, I have to add 1.5. That's what the common difference is. Write the sequence as a recursive function. So here's the formula. Take the previous term and add the common difference, 1.5. There's a formula. Give the first 7 terms. Well, here, u sub 1, the first term is a 3. U sub 2, the second term is 4.5. Now to find each term following, I would take the previous term. So 4.5 plus 1.5 is 6. 6 plus 1.5 is 7.5. 7.5 plus 1.5 is 9. 9 plus 1.5 is 10.5. We want 7 terms. 1, 2, 3, 4, 5, 6. We need one more. So I take 10.5 plus 1.5. We get a 12. So those are the first 7 terms of the sequence, where the first term is 3. The second term is 4.5. It is arithmetic, so that tells me that I'm going to be adding or subtracting the same number. The difference between the values is 1.5. I listed them out. Now, if I want to graph the sequence, remember this actually represents ordered pairs. The first term is a 3. The second term is 4.5. The third term is 6. The fourth term is 7.5. The fifth term is 9. The sixth term is 10.5. And our 7th term is 12. So I can graph this sequence as a scatter plot. I only need to look at quadrant 1 because all of my values are positive. So I'm only going to the right and upwards. I go to the right 7 units. 1, 2, 3, 4, 5, 6, 7. I have to go upwards 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now, in order to graph, you just do a scatter plot. That means you have unconnected points at every ordered pair. Right 1, up 3. Right 2, up 4.5. Right 3, up 6. Right 4, up 7.5. Right 5, up 9. Right 6, up 10.5. Right 7, up 12. So you can see it does have a linear pattern. Here is a full example and kind of tying everything that we've talked about so far about sequences, how you can graph them, being able to list the numbers, writing those formulas for them, those recursive formulas, all of those things. It's kind of tying them together in one. Now we're going to take it a step further. In the previous example, an arithmetic sequence was expressed in the recursive form, meaning you had to have u sub n minus 1, meaning take the previous term. Arithmetic sequences can also be expressed in a form that uses n, meaning if you want to find the 20th term, you can fill a 20 in for n. When that happens, it's called an explicit form. Okay, so we have an explicit form of a sequence, and that's what we're going to go ahead and look at now. Okay, here is a recursive formula. They want to show us that we can actually get the same result using an explicit formula, which is right here, using an n, and a recursive formula with the u sub n minus 1. So we're going to go ahead and first we'll do the recursive formula, create a table like we did in the first section. My formula is u sub n minus 1 plus 4. Then I would have my u sub n. When you have a recursive formula, the first term is always given to you. That's one of the rules. So the first term is given, it is a negative 7. The second term, it says use the previous term. So negative 7 plus 4 is a negative 3. The third term, use the previous term. So it's negative 3 plus 4 is a 1. To find the fourth term, use the previous term plus 4. 1 plus 4 is 5. To find the fifth term, and that's where we'll stop. We'll just go ahead and find the first 5 terms and see if they're the same. You use the previous term, which was a 5. 5 plus 4 is 9. So using this formula, the recursive formula, and starting with -7, I can see that the first 5 terms are -7, -3, +1, +5, and 9. Now this is called an explicit formula, okay? I can simplify this a little bit, and that's what I'm going to go ahead and do. Rather than keeping parentheses and multiple operations, I could have -7 plus 4 times n is 4n minus 4 times 1 is 4. If I combine the like terms to find my formula, it is 4n minus, because it's -7 minus 4 more is -11. So this is what our explicit formula looks like. It contains an n. That means if you want to find the first term, you put in a 1. If you want to find the second term, you put in a 2. So let's go ahead and make a table so we can compare these. So I have n. N is the number of term. 4n minus 11, that is my formula. U sub n, that is the result. So if I want to find the first term, 4 times 1 minus 11. 4 times 1 is 4. 4 minus 11 is -7. If I want to find the second term, I change n into a 2. 4 times 2 is 8. 8 minus 11 is -3. To find the third term, 4 times 3 minus 11. 4 times 3 is 12. 12 minus 11 is 1. To find the fourth term, 4 times 4 is 16. 16 minus 11 is 5. To find the fifth term, 4 times 5 is 20. 20 minus 11 is 9. So notice this was called an explicit formula. It contained just an n. This is a recursive formula. It contains u sub n minus 1. We ended up with the same result, -7, -3, 1, 5, 9. So those two rules, so to speak, are equivalent to them. And so by doing this, we can see that arithmetic sequences can be written in 2 forms. There is a recursive formula, that's u sub n minus 1, and there's an explicit form, that is when you just use an n, okay? We are going to go ahead and work with the explicit form a little bit more. There is a general rule, sorry about that. There is a general rule that we can use to write an explicit form of an arithmetic sequence. What you have to do is first start off, u sub 1, that is the first term. N, that is the variable that you're going to leave in the problem because your explicit form has to have an n in it. So it's n minus 1 times d. D is the common difference. If you are adding from one term to the next, that will be a positive number. If you are subtracting to go from one term to the next, your common difference will be negative. And it's okay for them to be positive or negative. So let's go ahead and try a few. Write the explicit form of the arithmetic sequence if the first term is -5. That's what u sub 1 is. So -5 plus n minus 1. And the common difference is 3. So it's times 3. So I set that up. Now let's get rid of the parentheses by distributing. So -5 plus 3 times n is 3n minus 3 times 1 is 3. Combine the like terms, so I have 3n, -5 minus 3 more is a -8. There is an explicit formula to find whatever number of term you would like to find if your first value is a -5, and to get from one term to the next, you are always adding a 3. Okay, let's go on to the next one. What is the 45th term? So this is why this formula is it's pretty darn helpful. If you were doing recursive and they wanted 45th term, you would have to actually go all the way through 45 terms. Because in order to figure out the 45th term, you would need the term before it, which would be the 44th term. So that's why explicit is helpful if you are looking at terms that are further along in the sequence. So let's go ahead and look at this. So u sub 1, the first term in the sequence is a 5. D, we need to know D. How do I get from one term to the next, adding or subtracting? To go from 5 to 9, I add 4. To go from 9 to 13, I add 4. because I'm adding 4, the common difference is 4. So let's set this up. It's the first term plus n minus 1 times d. Distribute, so 5 plus 4n minus 4. Here is the formula to find any n. It is 4n. 5 minus 4 is 1. Now this time it did not say find the formula. This said what is the 45th term. So to find the 45th term, you just simply fill in 45 for n. So if I take 4 times 45 plus 1, my 45th term of that sequence would be 181. Okay, let's look at one more like this, and then we're going to step it up a little bit more, okay? What is the 38th term of an arithmetic sequence if the first 3 terms are 15, 10, and 5? So my first term is 15. Now we need to find the common difference. How do I get from one term to a next, adding or subtracting? To go from 15 to 10, I subtract 5. To go from 10 to 5, I subtract 5. So your common difference is a negative 5. So the first term is 15 plus n minus 1 times negative 5. When I distribute, that negative has to go with. So 15, negative 5 times n is negative 5n. Negative 5 times negative 1 is positive 5. So our formula, negative 5 times n, 15 plus 5 is 20. There is a formula that can help us find any term in the entire sequence. You could put what is the 1,000th term, and you could put 1,000 in there. That'd be awesome. Okay, we want to find the 38th. So u sub 38, so negative 5 times 38 plus 20. So I'm going to go ahead and calculate that. Negative 5, n is a 38, plus 20. The 38th term would be negative 170. Okay, so here's a general idea for an explicit formula. However, there might be scenarios where you do not know the first term. Okay, we have to figure out a way that we could still create an explicit formula or a recursive formula, okay? So what they're telling us here is the 6th term is 57, and the 10th term. We do not know the 7th, we do not know the 8th, we do not know the 9th, hey, but we know the 10th, okay? The 10th is 93. Well, I can use this information to figure out D, because it's telling us it's an arithmetic sequence. So I have to be adding the same value every time to get from a 57 to a 93. So what you do to find D, largest number minus smallest number, so the furthest number out in the sequence. So 93 minus 57 divided by how many times are you adding the common difference? 1, 2, 3, 4 times. If I take 93 minus 57, that's a 36. 36 divided by 4 is 9. So this means our common difference is 9. So 57 plus 9 is 66. 66 plus 9 is 75. 75 plus 9 is 84, and 84 plus 9 is 93. Now I filled those out just to make sure that we were correct. Now what we have to do is we have to figure out what is u sub 1. That's the next step. So you start with the first term that we know. So we have to go u sub 6 equals u sub 1 plus, we know the 6th term, so it's 6 minus 1d. Okay, so it's the first term that I know. I can fill in some of these values. U sub 6 is 57. We do not know u sub 1. Plus 6 minus 1 is 5 times d. We just figured out d. D is 9. So my formula, I'm just going to head right up over here. 57 equals the first term plus 5 times 9 is 45. If I minus 45, I would have 2, 1. So my first term is a 12. Now from here, they want us to find a recursive formula and an explicit formula. Okay, recursive. To find a recursive formula, it is u sub n minus 1. Take the previous term. The common difference is positive, so you add 9. To find an explicit formula, u sub n equals the first term, 12, plus n minus 1 times d. Distribute, so 12 plus 9 times n is 9n, minus 9 times 1 is 9. Combine like terms, and I have 9n. 12 minus 9 is 3. So here's an explicit formula. Here's a recursive formula. They would both help you to find all of the terms that you would need for that particular sequence. Now I realize that was a lot of steps. So we are going to do one more example like that, okay? If u sub n is arithmetic, so they're telling you to get from one term to the next, you are adding or subtracting the same value, okay? We know the fifth term, not the sixth. The fifth term is 22. And we know the 11th term. We do not know the 7th. We do not know the 8th. We do not know the 9th, the 10th. But hey, check this out. We know the 11th is 64. Awesome. Now here I can tell that my common difference is positive because I'm starting here at 22. And as I go further into the sequence, I end up with a larger number. So I must be adding a value versus subtracting. To find d, the furthest value out is 64, minus the first value I know, it's 22. Divided by how many times are you adding? We are starting at 22, we add 1, 2, 3, 4, 5, 6 times. If I go ahead and I take 64 minus 22, I get 42. 42 divided by 6 is 7. So now I know my common difference. 22 plus 7, well, that's 29. 29 plus 7, that's 36. 36 plus 7 is 43. 43 plus 7 is 50. 50 plus 7 is 57. 57 plus 7 is 64. Now, the reason why I did that is just to check and make sure that our common difference was correct. Now what I need to do is find u sub 1. That's our next step. So to find u sub 1, you start with the first term that you know. We know u sub 5. We do not know u sub 1. We are using the fifth term, and we need the common difference. Okay, so now at this point, I'm going to fill in what I know. U sub 5 is 22. I do not know the first term. I am using the fifth term. The common difference is 7. So 22 equals u sub 1 plus 5 minus 1 is 4. 4 times 7 is 28. If I minus 28, 22 minus 28 is a negative 6. So my first term is negative 6. My common difference is 7. If I am writing a recursive formula, recursive formulas go really, really fast. Your formula is take the previous term, the common difference is positive, so you add 7. That is your recursive formula. All you need is the difference. Now to find the explicit. Now the explicit I think is more helpful. That's why it's important to know both forms. You take the first term, negative 6, plus the number of term you're looking for, minus 1, times the common difference. Distribute negative 6 plus 7 times n is 7n, minus 7 times 1 is 7. So my formula, combine like terms, I have 7n, negative 6 minus 7 more is a negative 13. There is an explicit formula as well as a recursive formula for that particular sequence. Your assignment is on page 29 in your textbook. You are doing numbers 1 through 6. You do not have to graph those, okay? I know that we've worked with graphing sequences quite a bit. I did do one in the examples just to remind you how that works. So to save you a little bit of time, when you are doing 1 through 6, even though the textbook says graph, don't worry about it, okay? And then jump ahead and do 25 to 30. And we will look at sequences a little more tomorrow. Have a great day.